Welcome to this session, TDD. It's about more than just the tests. My name is John Turner. Just a little bit about me to get us started. I'm a software developer. I work at a company called Immersion. We do automated online language proficiency evaluations. So if that sounds cool to you, go ahead and check out our website, or you can talk to me about it. Speaking of contacting me, here's my email address. If you want to talk to me more about test-driven development or other technical practices, feel free. I also put my LinkedIn profile here if you want to connect with me on LinkedIn and message me that way. That's also cool. I put my personal website here if you want to go look at weird retro ASCII-based games that I've made and other stuff like that. Feel free. And then finally, I also added a link to the slides if you want to go back and review them later. You can go ahead and do that. I'll also put a link to the slides at the end of the presentation. When I do a presentation, I like to give just at the beginning a really quick synopsis of what we're going to be talking about so that you can decide at the beginning of the presentation if it's what you're looking for or if you need to go find a different one. So what are we going to talk about? In this session, we're obviously going to be talking about test-driven development. I have maybe 10 minutes worth of slides, and then the rest of the presentation is going to be me coding. So if watching me write unit tests for 40 minutes sounds like your jam, this might be the session for you. If not, maybe you want to go find a different session. And if so, that's okay. We can still be friends. All right, so we're going to talk about test-driven development. In talking about test-driven development, let's start by talking about what test-driven development is not. I've talked to a lot of developers who incorrectly equate test-driven development with writing code that has unit tests. Well, that's oftentimes a part of doing test-driven development. It's not the same thing. I've also talked to developers who think that test-driven development is writing unit tests for code, but writing those tests beforehand. And while that again is a part of test-driven development, it isn't test-driven. It's not the same thing as test-driven development. In talking about getting more to what test-driven development actually is, let's talk about what some of the goals are of test-driven development. It's kind of unfortunate actually that test-driven development has the word test in it because it's not actually really about the tests. In the fact that we end up with tested code at the end is a nice benefit, but it's not really the primary goal. In my opinion, at least anyway, there are two primary reasons for doing test-driven development. The first one is as a decomposition tool. As software developers, we're often given the assignment to address big, complicated problems that we have no idea how to solve. And so what we do is we take that big, complicated problem that we don't know how to solve and break it down into smaller problems that we also don't know how to solve. And then we take those problems and break them down into smaller problems that we also don't know how to solve. And we continue that process until eventually we get to the point where the problems are so small that we do know how to solve them. That process is called decomposition, and test-driven development is a great tool for doing that. One of the other main reasons, in my opinion, for doing test-driven development is because it helps you to create more simple and more maintainable code. Test-driven development is a design technique rather than a testing technique. And hopefully in the coding part of this session, you'll be able to see some of the effects of that. So let's talk for a minute about the 3 rules of test-driven development, sometimes also called the 3 laws of test-driven development. The first one is that you're not allowed to write any production code unless it is to make a failing unit test pass. So this is where the test first part comes from. Before I can start writing production code, I have to have some test code, and that test code has to be failing. So that's our first rule. Our second rule is you're not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. So this is one of the 2 rules that forces us to write in very small increments, which is a difference than just writing unit tests before our production code. And then the third rule is you're not allowed to write any more production code than is sufficient to pass the one failing unit test. This one also forces us to work in small increments, small iterations. and this is the rule that keeps us from writing one unit test and then going off and writing our entire system. So these are the three rules of TDD. Oftentimes when you're doing TDD, you find yourself, and following these rules, you find yourself falling into what's called a red-green refactor cycle. So let's talk about that Let's talk about that for just a minute and what that looks like. So in the red-green refactor cycle, there are three different phases. The first one is red. That's where you write a test that fails, and following the other rules that we just saw with TDD. Once you have a test that is failing, then you go to the green phase. This is where you make that test pass. You make that test and all other tests that you have previously written pass. Usually you do it using the simplest thing that could possibly make the test pass. You just want to get code that works first, because after the green phase comes the refactor phase. This is where you get code that's not just right, but you get code that's good. If you're not familiar with the term refactoring, one very important thing to remember is that refactoring is a change in form, but not a change in function. So in this phase, I'm not going to be adding features or taking features out or changing functionality in any way, but I can make the code better during this phase. So I can simplify code. I have a couple examples here. I can simplify code. I can rename things. I can extract methods, remove duplication, things like that. So this is the red-green refactor cycle, and in the coding portion of the presentation, we'll see this. We'll go through this multiple times. Okay, you'll notice in the green phase I said do the simplest thing that could possibly make the tests pass. That sort of idea comes from these two gentlemen and a couple others also. But these two gentlemen are Kent Beck and Ron Jeffries. They're two of the original Agile Manifesto authors. They worked together for a period of time. Kent Beck, the story goes that Kent Beck used to say, what is the simplest thing that could possibly work when they were trying to solve a problem? And Ron Jeffries changed that to, rather than asking what the simplest thing is that could possibly work, let's just go ahead and do the simplest thing. So in the coding portion of this presentation, I'm going to be invoking Ron Jeffries a lot and saying, well, what would Ron Jeffries tell us to do? Whenever I do that, think to yourself, do the simplest thing that could possibly work. So we're gonna hit on that a lot. All right, let's move to some code. Before we do that, let me just give you a little bit of an introduction. For the purposes of this presentation, we're going to be doing what's called a code kata. The term kata comes from martial arts. It's a form of practice. A code kata is the same kind of thing. The goal is to practice. The goal with a code kata is not necessarily to prove that you can solve the problem, but it is to practice something. For example, you could use a code kata to practice a new programming language or to practice features of an existing programming language that you're not familiar with those features of the language. In this case, we're going to use a code kata to practice test-driven development and to demonstrate test-driven development. The code kata that we're going to use, it's called the Roman numeral kata. The goal is to write some code that converts what are usually referred to as Arabic numerals. So those are the numbers 0 through 9 in decimal format. Most of us probably learned those types of numbers in school. We're going to convert those types of numbers into Roman numerals. If you're not familiar with Roman numerals, most of it is fairly simple. 1 is represented with I, 5 is represented with V, 10 is represented with X, and there are some more cases beyond that. And then you can combine letters to make bigger numbers. For example, the number 2 is represented with I. You think of it as 1 plus 1. Number 6 is represented with VI, 5 plus 1, and so on. The biggest complicated part, I guess, of Roman numerals is what I call the subtractive cases. There are a few cases where, for example, 4, rather than being represented by I, it's actually represented with I followed by a V. So 6 is VI, 5 plus 1, 6. 4 is represented by I followed by a V. So the way I think of it is 1 subtracted from 5 gives us 4. So there's several of these subtractive cases that are a little bit more complicated. So 4, 9, 40, 90, and there are a few others as well that we'll get into in the coding exercise. Okay, so with that description of our code kata, converting Arabic numbers to Roman numerals, I want you to take just a minute to think about if you were given the assignment at work or wherever, or school or whatever, to implement a solution to this problem. Think for just a minute about what that solution, and you just started writing code. Think for a minute about what that solution might look like. What kind of control structures might you use? What kind of conditionals? What kind of edge cases would you have to deal with? Do like a little, write a little bit of pseudocode in your head, if you will, just kind of thinking about, oh, well, what would that solution maybe look like? Okay, and keep that in your mind. We'll come back to that in a minute. All right, so with that out of the way, let's go and move over to Visual Studio Code, actually write some code. Here I have a brand new C# project using a testing framework called NUnit. If you're not familiar with C# or NUnit, that's okay. The things we're going to talk about should apply to pretty much any programming language or testing framework. Here I happen to have, down at the bottom, I have a test runner running. So anytime I change the files, it'll automatically recompile my code and run all my unit tests. You can see I have one unit test that is passing right now because I have this one here that just does an assert.pass, which isn't very interesting. So now we're going to do the actual test-driven development flow, red-green refactor, all that sort of stuff. As our first test, we're going to we should when we're doing test-driven development, we should always be thinking about what test case we're working on now, which one we're going to be working on next. For this first one, we could start thinking about, well, what kinds of test cases could we test first? Things like 1 should convert to I, or 5 should convert to V, or maybe 2 should convert to II, or something like that. For this first test case, I'm going to choose to do sort of an edge case for Roman numerals. I'm going to do the case of 0. Now, technically, in Roman numerals, 0 is not defined. They didn't have the idea of 0. So what I'm going to do for the purpose of this demonstration, I'm going to say that if for the code that we're going to write, if I pass in 0, it should return empty string. So it's not going to return any I's or V's or anything like that, just an empty string. So I'm going to start by writing that test. 0 returns empty string. We'll do that. And I'm going to say assert that Arabic to Roman dot convert. If I pass in 0, that should be equal to an empty string. You can see down here, I just auto-save my code, and my test failed, and says that the name Arabic to Roman does not exist. So if you remember back to the rules of TDD, we should start with a failing test, and compilation is a type of failure. So right now, I have a failing test. I'm in the red phase. I have a failing test that's failing because I'm calling this Arabic to Roman thing, which doesn't exist. It's code that I haven't written yet. This is going to be my production code. So I'm going to go ahead and generate a little bit of code for that. I'm going to just put it here in the same file where I'm writing my test code. If I were actually doing this for like real work code or something like that, I would probably put my unit test code and my production code, I'd have them more separated in separate projects or directories or something like that, so that I don't have to deploy my test code. But for the purposes of this demonstration, we're just going to put them in the same place so I don't have to keep switching back and forth. Now you see I added an Arabic to Roman class. C# is an object-oriented class, and I added a convert method. And my test just ran, and it failed because it says the method or operation is not implemented. So now I have a test that is failing because it's checking that a piece of functionality is working correctly that I haven't written yet. So this is the red phase. I have a test that's failing for the reason that I want. Now I move to the green phase. This is where I make that test pass. And if you remember back to, I mentioned Ron Jeffries, we should do it using the simplest thing that could possibly work. So think to yourself for just a minute, what's the simplest thing that could possibly work? Hopefully you came up with something like return empty string. And if we wait for our test to pass, you can see it does pass. Now you may be saying to yourself, wait a minute, return empty string. That's stupid. That's not going to solve our problem. You're correct. It is stupid and it's not going to solve our problem, but it will solve a little bit of our problem. Remember that test-driven development is a decomposition tool, so it's going to help us break big complicated problems like converting Arabic numbers into Roman numerals and down into small problems that we can solve. I don't know about you, I can solve the problem of returning an empty string. Okay, so we got to the green phase. Now we move to the refactor phase. We don't have a lot of production code at the moment. We basically have a return empty string, which isn't super interesting at this point. So I'm going to choose to skip the refactor phase. The refactor phase is optional. And I'm going to move on to go through the red-green refactor cycle again. I'm going to move back to red. So now I get to add another test. So I've added this 0 returns empty string test. I'm going to add my second test. For my second test, I'm going to choose to do the one case, the much more traditional Roman numeral conversion. So I'm going to say 1 returns empty string. I'm going to say assert that if I call my Arabic to Roman convert method and pass it 1, this time it should return I. And if I let my test run, you can see that it, in fact, does fail. And it says expected I, but returned empty string, which makes sense, hopefully, because the only code that we have so far returns empty strings. So I'm done with my red phase. Now I go to my green phase. Now I make the test pass. And again, going back to Ron Jeffries, do the simplest thing that could possibly work. What is the simplest thing that could possibly work that would make my new test pass while still allowing all my previous tests to pass? Well, I know that this return empty string case, I know that that works if the Arabic value that gets passed in is 0. So I'll go ahead and add a conditional. And then say, in the 0 case, return an empty string. Otherwise, just always return 1. Now, you may be a little underwhelmed with this code. It's like, okay, we just added a conditional and another return statement. Really? Is that, like, can this guy even code? What other sessions are going on during this time period? That's totally valid. You should be asking yourself that. We'll probably have 1 or 2, maybe 3 other more instances where the appropriate response is to say, really? Really, that was it? What else is going on during this time slot? But it will get better, I promise that. Okay, so we have completed our green phase. Now we're going to go move on to refactor. Again, we don't have a whole lot of production code going on, so I'm going to choose not to refactor anything there. If we come up here and look at our tests, though, the 2 tests that we have so far are looking pretty similar. There's possibly some duplication there that we could remove. At the moment, we only have 2 instances. I usually like to wait until we have 3 instances before I remove duplication. So I'm going to choose not to do any refactoring there at the moment, and I'll move on and go through the cycle again, go back to red. So now I'm going to add a 3rd test. Now it starts to get a little bit more interesting. One thing with test-driven development is, since we're working in these very small increments and doing 1 unit test at a time, we have a choice about what order we implement those tests in. Sometimes the order that we implement those tests can have an impact on the design of our code. So some possible choices that we could have, next test that we could do here, we've done 0 and 1, we could do 2, that would force us to start doing multiple characters. We could do 5 should go to V, if you remember. That might be a good one. We could do 4, but that just sounds super complicated. So let's not do that. 2 seems, for me at the moment, 2 seems like a little bit bigger of a step than I want to take right now. So I'm going to go for the 5 case. So I'm going to say 5 should return V. Oh, I did this wrong too. 1 doesn't return empty string, 1 returns I. Let's see, let's do assert that Arabic to Roman, if I call my convert method and pass it 5 this time, that should be equal to V. And if my tests run, 1 of them should fail, and you can see it expected V, but it was I, which makes sense because we're just always returning I in anything except for the 0 case. So we're now done with red. Now we go to green. Now we make that test and all of our previous tests pass. Again, going back to Ron Jeffries, doing the simplest thing that can possibly work, right? Well, what's the simplest thing that could possibly work to make that test pass? Okay, this is another time when you're probably going to be underwhelmed. Going to add another conditional. Okay, again, at this point, you should be saying to yourself, really? Let me go check the schedule. Like, what else is going on? Is there something else that's more useful going on right now? Well, I promise, it will get better. It will get better. You can see here, so now we're done with the green phase. Our tests do indeed pass. Now we're to the refactor phase. Here you can see we're starting to, well, maybe these two lines, lines 31 and 32, maybe there's some duplication there that we can get rid of. Maybe. I'm going to choose not to do any refactoring there just now. But up here on our tests, we have some pretty clear duplication. We have 3 tests. The only difference between them is the Arabic number that we're passing in and the Roman numeral that we're getting back. So I'm going to go ahead and refactor my test code to get rid of that duplication. Now, I mentioned I am using a testing framework, a unit testing framework called NUnit. It has a nice feature in it called a test case that handles tests like this super well. So I'm going to do a test case, and I'm going to give it a 0 and an empty string. And then we're going to make another method here called conversion tests. And it's going to take an integer, which is going to be my Arabic value, and a string, which is my Roman value. I'm going to say assert that Arabic to Roman.convert. And then instead of passing it a hard-coded Arabic value, I'm going to pass it whatever Arabic value got passed into the method call. I'm going to say that should equal, again, rather than a hard-coded Roman numeral value, it's whatever Roman numeral value got passed in. The nice thing about this, you may be saying this looks pretty similar to the test we already have. The nice thing about this is I can go, if I want to add additional invocations of this method with different parameters, I can just make another test case. This is called, in C#, this is called an attribute. So I can add another test case attribute for these other tests. So this conversion tests method will get called 3 times because I have 3 test cases. Once it will get called with 0 and empty string. The next time it will get called with 1 and I. Next time it will get called with 5 and V. And you can see down here I have 6 tests passed. NUnit counts as each of these test cases as its own test. And so those are now duplicates of these tests that we already have. So I can go ahead and delete them. All right. And if we run my tests again, you'll see now I have 3 and they all pass. Okay. So that was our refactor phase. I'm going to go through the cycle again, go back to red. So I'm going to add a failing test. Now this time, I have a couple options again. I could add 2. That would force me to start dealing with more than one character at a time as a return value. I could do 10. 10, you can kind of think in your mind what that would look like. I'd probably add another conditional here and return X. That doesn't really drive our code forward a whole lot. So I'm going to go ahead and add the 2 case. And if you see, it fails. All right, so that's the red phase. Now to do the green phase. Again, doing the simplest thing that could possibly work. What is the simplest thing that could possibly work to make this code pass? Again, you're going to be underwhelmed with my coding abilities. I'm just going to duplicate this line and say 2 is going to return II. Now, again, this is another time when you should be saying to yourself, what's going on during this time slot? Is there another session where there's someone who can actually write code? There probably is. This is going to be one of the last times, I promise. It's going to start getting a little bit more interesting at this point. So again, you may be saying to yourself, oh man, this is really pedantic and annoying because we're just adding these onesie twosie cases like this. It's not really driving our code forward. You're completely right. The good news is that Roman numerals are only defined up to 3,999, so we only have 3,996 more cases to go, and then we'll be done. No, that's not what we're going to do. It's going to get better. Okay, so if it may have looked like I did the exact same thing that I did last time, where I just added a conditional. I actually did something a little bit different in this situation. I did it quickly, so you may not have noticed it. rather than adding something to an existing line, I actually took line 23 and completely duplicated it and then modified it. That's actually a clue to us that there may be some duplication. And in fact, there is. So we're at the green phase. Our tests have passed. Now we're moving on to refactoring. I want to remove the duplication between lines 23 and 24. I want to collapse them down both into a single line. Now, just looking at it, you can see, well, there's kind of some duplication there, but how are we going to combine those two lines? I'm going to do a couple of refactorings to help make the duplication more apparent. So the first thing I'm going to do is this string II, I'm going to break it up. And that's really the same as taking the string with one I and concatenating it with the string with another I, right? I haven't changed any functionality, and you can see in my tests still pass. I haven't changed any functionality yet. Okay, so, you know, those two lines are looking a little bit more similar. Let's see if we can actually make it so that we can collapse them together. So this second I in the to case, I'm going to replace that because I already have code that can generate the character I. All I have to do is call my convert method, passing it the right value. If I pass it 1, I'll get back I, right? So I'm going to do a recursive call here, and you can see my tests still pass. Okay, let's make this a little bit more generic so that it could work for both the one case and the two case. Instead of always passing 1 here, I'm going to say, well, let's pass Arabic -1. So in the case where I pass in 2, it'll be 2 minus 1, which is 1, which is still the value that I'm going to pass in, which is still the correct value. Okay, now let's see if we can change this condition here so that it handles 1 and above. So it'll handle 1 and 2. And you can see here our test failed because we made this conditional, we made it too broad. It's taking over the 5 case now, which is we don't want it to do because we have something else to handle 5s, right? So we're going to go ahead and say, well, if it's greater than or equal to 1 and it's less than 5, so that it won't take over the 5 case. Then you can see it does still pass. You may be saying to yourself, well, this is a little bit ugly, and I will agree with you, it is. It's a little bit ugly. Sometimes when we refactor, our code gets uglier before it gets prettier. And this is an example of that. It will get prettier, I promise. But for now, it'll be just a little bit ugly. Okay, but our goal was to collapse these two lines into a single line. Let's see if we can do that. If we comment out the one case, do our tests still pass? And in fact, they do. So I'm going to go ahead and delete that line. So we've collapsed the one case and the two case together in our refactoring step here. Okay, I'm good with where we're at from a refactoring standpoint. Now we're going to go through the cycle again. Go to red. Now we have some interesting choices before us. We could add a 3 case. I actually think the 3 case will already pass. If you thought maybe you could add a test case, but it might already pass, go ahead and add it if you want to. And then if you still find value in it, leave it. If not, if you're like, oh yeah, I thought that would work, and it really did, and it's not valuable to you, then you can take it out. I think the 3 case will already pass here. So I'm going to work on making lines 23 and 24 a little more similar now. And to do that, I'm going to add the 6 case. So you can see our test failed. We're done with the red phase. Now on to the green phase. What's the simplest thing we could do that could possibly work? Well, I'm going to do something similar on this 5 case to what we did on the 1 case. I'm going to do another recursive call, but instead of doing Arabic -1, I'm going to do Arabic -5, right? So if we pass 6 in here, we'll print out a V, and then we'll do a recursive call to convert with 6 minus 5, which is 1, which will give us an I, right? And you can see our tests agree with us. Okay, so now you can start to see that there's some duplication between lines 24 and 25. I'm done with the green phase. My tests pass. I'm going to do refactor. I'm going to choose not to refactor yet. I want to make the duplication between those two lines more obvious. So I'm going to go through this cycle again, go to the red phase. I'm going to choose to add 10. This will help to make the duplication between these two lines very obvious. So you can see my test ran, expected X but got VV, which kind of makes sense. You know, it's two 5s added together. All right, again, simplest thing that could possibly work. I'm going to add our good friend, the conditional clause here. So I'm going to say if our Arabic value is greater than or equal to 5 and our Arabic value is less than 10, go ahead and do this 5 case. Otherwise, return X for 10. And you can see that passed. All right. So now we have, now we're done with green, our test passed. Now we're going to do refactor. This is where it's going to get a lot more interesting. It's going to get a lot more exciting because this is going to be probably our biggest refactor of the whole coding exercise. If you'll notice in lines 25 and 26, we have a very strong implied mapping between 1 and I, right? And between 5 and V. And it's not super fleshed out yet, but we do have an implicit mapping between 10 and X as well. So rather than having, in our refactor phase, rather than having those mappings be implicit, I want to have them be explicit. So I'm going to come up here and create a data structure to store that mapping. I'm going to create a list. I'm going to create in C# it's called a list. That's just an ordered collection. I'm going to create a list of what are called tuples. If you're not familiar with tuples, a tuple is just a grouping of things. In this case, I'm grouping an integer with a string. If I were in a language that didn't have tuples, I could just create my own data structure that associated an integer and a string together. But C# happens to have tuples built in. So I'm going to use those. And I want to, in this list of mappings, I want to associate the number 10 with the string X, the number 5 with the string V, and the number 1 with the string I. So I've created this list of mappings. I'm not using it yet, so you can see my test still passed. I haven't done anything there. What I want to do down here is start using those mappings. Thinking about passing in Arabic values and selecting mapping, picking the right mapping for the right Arabic value in a generic sense, it can be kind of hard to think about. So I like to use an example. Assume that I'm calling the convert method and I'm passing in the number 6. If I go and look through these mappings, I don't want the 10 mapping because that doesn't have anything to do with 6. So I should skip that one. I should pick the 5 mapping because the value that I'm going to return, VI, starts with a V. So I should pick the 5 mapping first time. So I'm going to write some code that will pick that first mapping correctly. So I'm going to say the one mapping that I want is, I'm going to look at my, oops, named this one wrong. This should be mappings because there's more than one of them. Mappings. And I'm going to use a C# language feature called link, which stands for language integrated query. It's just a set of helper functions that let you iterate over collections in a generic way. This particular one that I'm going to do is called first. It will iterate over this mappings collection, and it will find the first element of that collection that meets some criteria that I pass in. So I can pass that in using what's called a lambda. It's a type of anonymous function. So I want to find the first mapping where, now I'm going to go and make one little change because with C# in tuples, the things that you associate together by default are named item 1 and item 2, which are terrible names. But C# allows you to name the components of your tuple. So I'm going to call this the integer part, whoops. There we go. I'm going to call the integer part Arabic and the string part Roman. This is what happens when you talk and type at the same time. So the integer part of the mapping will be called Arabic, and the string part of the the tuple will be called Roman. So I want to say find the first mapping in my list of mappings where the Arabic component is less than or equal to the Arabic value that got passed into my convert method. So this Arabic method, this Arabic value is this Arabic value. This Arabic value is one of these integer values. So you can think of it as I'm going to iterate through this list using our example 6. Is 10 less than or equal to 6? No, it's not, so it's going to skip that one. Is 5 less than or equal to 6? Yes, it is, so it will select this one. If you were doing this in a language that didn't have link or something like it, you could just manually iterate over this collection and find the one that is the first one that is less than or equal to the Arabic value that got passed in. That would make the solution a couple lines longer, but it would be functionally equivalent. Okay, so now once I have this 5 to V mapping, again in our 6th example, I'm going to say take that mapping and return the Roman part, V. And I'm going to do my my recursive call like I'm doing down here. I'm going to take the Arabic value that got passed into my convert method, which again in our example is 6, and subtract from it the Arabic value from the mapping, which is 5. So it's going to do 6 minus 5, which will be 1. And I'm going to return that. And you can see our tests pass, and also I'm getting a little squiggly here telling me that these lines aren't actually used anymore. That it can't ever get to those lines. So these 2 lines, along with our mapping collection up here, is the same as these 3 lines. Okay, again, this is so I'm going to go ahead and delete those lines. Again, this is probably the biggest refactor that we're going to do in this whole exercise. So hopefully I didn't hopefully I didn't lose anyone too much there. Again, we're just going to go through this list of mappings, find the first one where the Arabic component is less than or equal to the Arabic value that got passed in, and we're going to return the Roman part of that, V, again in our 6th example. We're going to return the Roman part of that and do our recursive call to get the rest of the Roman numeral. Okay, so hopefully you're still with me. Again, this was probably the biggest refactor that we're going to do. That said, we are in the refactor phase. I think we did enough refactoring. I'm going to go through the cycle again, go back to red. Now we have a much more general purpose solution, and we should be able to handle a lot more cases now. So for example, just to prove to ourselves that this does work, what about 11? 11, you can see, already works. So that's pretty cool. In fact, now we're to the point we can start doing some of the other big cases, like 50. 50 goes to L. You can see it said expect L, but was 5 X's, which kind of makes sense. You know, X is 10, and we added 5 of those together. The really nice thing about our current solution is that in order to add these new cases, all we have to do is add another item to our mappings collection. And you can see 50 now passes. In fact, so we just did red and then green. I'm not going to choose to do any refactoring. We're going to go back to red again. I'm going to cheat just a little bit. I'm going to add 3 cases at one time. So 50 is a new letter, 100, 500, and 1,000 are also different letters. 500 is D, and 1,000 is M. And so I just added 3 cases. I should have 3 test failures. You can see I do down here. And so that was red. I'm going to do green. I'll go ahead and add all 3 of those in one step. 1, 2, 3. M is 1,000. 500 is D. And 100 is C. And now they should all pass. And you can see that they do. All right, let's take one quick little break and come down here and look at our convert code. So actually, before we look at that, now that we have the 50, 100, 500, and 1,000 case, and all the other ones we've done before, as long as I avoid the subtractive cases, I can do any Roman numeral, like 3,867, which if I Roman numeral correctly is MMMDCCCLXVII, I think. Let's see if I did that right. And I did. Yay, that's good. So again, as long as we avoid the subtractive cases, we can handle all of the Roman numerals. Now let's come down here and look at our code for a minute. You'll notice our solution is basically 3 lines long. We do have this mapping collection up here as well, but the main part of our code is these 3 lines of code. I want you to go back to the beginning when we were talking, when I was originally introducing this code kata, and I asked you to think of the solution that you would come up with if you just started writing code. Think of that solution. Compare it to this solution. Now, maybe you're a much better programmer than I am. You probably are. But for me, at least anyway, if I were to just start hacking away on code to solve this problem, I would have come up with a solution that was a lot different than the one that we came up with just now. I would argue that the solution that I would have come up with would have been a lot more complicated and probably a lot harder to maintain. And that this solution that we came up with was simpler and easier to maintain. And that the reason that we came up with simpler, easier to maintain code is because of how we wrote the code, specifically meaning that we used test-driven development to drive the design of our code. That's what I would argue. Again, maybe you're a way better coder than I am and you would have just come up with this, but I wouldn't have. Now you may be saying to yourself, wait a minute, John, what about those subtractive cases that you've been avoiding this whole time? What about those? When we put those in, that's going to we're not addressing those right now. When we put those in, it's totally going to screw up our code. I completely agree with you. We are not addressing those at this point. So let's go ahead and attack that one and just go ahead and add some subtractive cases. So again, we're going to go through red-green refactor again. Let's go ahead and add the for case. And then we'll go, once this fails, you see it fails. It expected IV but returned I, which makes sense. 4 I's together make 4. And now let's go and mess up this beautiful code, this beautiful simple code that we've written. But if you remember, we're going to go back to Ron Jeffries. What did he say? Do the simplest thing that could possibly work. What is the simplest thing that could possibly work that would make this test pass? I would argue that the simplest thing that we could do to make this test pass, rather than mess with our existing code, is we could just add another mapping to our list of mappings. And you can see that makes a pass. And but you might be like, wait a minute, it can't be that easy. Let's do another example to prove to ourselves that it is indeed that simple. We'll do the 9 case. 9 is IX. We'll just add another mapping to our list of mappings, and that passes. In fact, we can go ahead and add all the remaining subtractive cases. 40 is XL, 90 is CD, 400, 90 is XC, 400 is CD, and 900 is CM. So I just added 4 cases, should have 4 tests that are failing. And if I go ahead and add those cases to my mappings, and if I type them correctly, and 40 is XL, if I did that correctly, then all of my tests pass. So now I can handle any Roman numeral, such as 3,949, which would be CMXLIX, if I did that right. And you can see all of my tests pass. All right, so our code now handles all all the inputs that it's supposed to, and our solution is still essentially 3 lines long. Again, my argument is that I, at least anyway, would have not come up with code that was this simple and this maintainable if I had not done it using test-driven development. And that because we use test-driven development, we ended up with simpler, more maintainable code along the way. And it also now has test coverage. So if we need to change it in the future, we can do so with more confidence than we otherwise would. All right, let's go back to our slides for just a minute to wrap up. Some additional resources that might be interesting to you if you'd like a description of this code kata and would like to go through it yourself. I have instructions for that on the at that first URL. It's instructions that actually take you through the steps that we went through here during this presentation. If you can obviously, since this is a recording, you can obviously review it later if you want to, but if you'd prefer to review the solution in code using git commits, that's the second URL there. If you'd like to see someone else also implement a solution to this problem using test-driven development, Corey Haynes has a great video of him doing it. He does it in Ruby. So if you don't like C# and you prefer Ruby, you can do that. If you're interested in test-driven development and other technical practices like pair or mob programming or continuous delivery or things like that, the company that I work for, Immersion, we have what we call a guest mobber program where you can come and you can sign up to come for a couple hours to come and code with us, just on whatever we happen to be working on that day. Since we use mob programming, we all work on it together. And so if you are a coding wizard, we'd love to learn from you. If you maybe are super awesome at doing return empty string statements, we'd be happy to help you and maybe help you learn some things. And again, the last link on there is a link to the slides, and there's a QR code for that as well. I hope this session has been interesting and informative for you and giving you some things to think about. Have a great day and a great rest of your conference.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.